Okay, hello everyone. Welcome back. In this video, we're going to talk about the concept and introduce this idea of Gibbs free energy. So the way that in our previous video, in part 6, that we figured out if a reaction was spontaneous was only at one temperature. And so in that example, at 25 degrees, we were able to find out that the combustion of propane was spontaneous at that temperature. But it turns out that many times we want to know about the spontaneity at a lot of temperatures. And in that case, we would have to go through and calculate delta S of the surroundings and delta S of the system at different temperatures. It turns out that that is a lot of work. And so what we really want to do is to figure out if we can determine if a reaction is spontaneous by only measuring the system. Now, you've probably figured it out that I wouldn't be setting this up or talking about this in this way if this were impossible. And it turns out that Gibbs free energy is the method that we use to be able to do this. And so, yes, we can, but we have to introduce this new term that is known as the Gibbs free energy. And so the Gibbs free energy is nothing but a derivation of our delta S of the universe. So if we start with our trusty delta S of the universe is equal to delta S of the system plus delta S of the surroundings, and then we know that delta S of the surroundings is equal to negative delta H of the system divided by temperature, we can plug this in, and that gives us this relationship. And then to get rid of this fraction, we multiply the entire equation by temperature. And to make things complicated, we're going to actually multiply by the negative of the temperature, which gives us this relationship. And so then we make a definition that delta G, Gibbs free energy, and this is the Gibbs free energy, is equal to this negative temperature times delta S of the universe. We can get an equation that describes spontaneity, because remember that see how this delta G is related to delta S of the universe, and we know that delta S of the universe defines spontaneity. Where delta S of the universe is greater than 0, things are spontaneous. And so that means that our Gibbs free energy is a different measure of spontaneity, and that relates only to the system, the delta S of the system and the delta H of the system. And it has this temperature term in there, which means that we can measure this at more than one temperature. Okay, and so what does Gibbs tell us? The Gibbs free energy tells us, the sign of the Gibbs free energy tells us if the reaction will be spontaneous, and the magnitude of the Gibbs free energy tells us how spontaneous the reaction is. And so if the Gibbs free energy is positive, the reaction is not spontaneous, because remember that delta G is equal to negative T times delta S of the universe. And so if delta S of the if Gibbs is positive, then that means that delta S of the universe has to be negative, and a negative delta S of the universe is not spontaneous. So if a delta G is less than 0, then the reaction is spontaneous. So if our delta G is negative, that means for a negative, for this side of the reaction to be negative, that means that the delta S of the universe has to be positive, because a negative times a positive is a negative. And a positive delta S of the universe is spontaneous. Okay, so in the next video, we're going to do more with the Gibbs free energy and begin doing some examples around this. I hope this derivation made sense to you, and keep coming to office hours, and I will see you later.